So today we have with us Shalabh Jain, who is a researcher at Bosch Research and Technology Center here in Pittsburgh. So Shalabh does a lot of work in automotive privacy and considerations related to kind of what security and privacy concerns that are introduced with kind of the evolution of different automotive technologies. So I'm really looking forward to learning more about that space, which we don't really often consider, but there is a lot of sensitive data collection that is going on with kind of the latest generation of vehicles. So definitely looking forward to learning more.
Thank you. So hi everybody. So I'm Shalabh Jain, and like I was introduced, we're talking about privacy in automotive. And even if you ask people in Bosch, is automotive data privacy relevant? A lot of people will end up saying no. So this thing that you've not heard of privacy in context of automotive is actually the assumption, by pretty much everybody. So the way that I've organized this talk is, I'll give you some high-level problems which exist in the automotive domain, and also some research aspects of it. Since everybody here is a student, so maybe we can get some breakthrough solutions from some of this. Just as an acknowledgement, so some of the architectures and frameworks that we'll go over here. So it's a broad team of researchers that works on this here and in Germany. And I'm also sort of advised to say that the frameworks here are not necessarily commercial products yet, and they might not become commercial products. These are research prototypes, which we hope will go into standards and become products. Right? How many of you know Bosch? Just as a okay, good number. But for those of you who don't, so Bosch is this gigantic German 400,000 people company. There's a small group of Bosch researchers, about 1,800, spread, across all countries basically. And the four thrusts in which we do research is mobility, consumer goods, energy, and industrial setup, right? Industrial technology. So, if we look at what a car looks like, so today's car, modern vehicles, right? They have these small electronic components. So you want to move your seat forward, you want to have your windshield wipers adjust to rain. Each of these is controlled by a small control unit. And in today's cars, there are about 100 of them, right? And it's growing in modern cars. And the way that this is all wired up is each of these small units is wired up through a bus that we call the CAN bus, right? Now going forward, what's going to really happen in software-defined vehicles, and this whole it's going to be a complete paradigm shift. There's going to be a few very powerful nodes which will be connected by actuators and sensors. Okay, so this is a complete change in the automotive architecture, and it's going to happen because there's a lot of benefits from a cost perspective. There's a lot of benefits from a features perspective that's going to be provided for it. Right. Yeah, and this has implications. So this architecture has implications, right? So the thing is that I think if you've been observing the automotive market, cars have already become more personalized, right? And this shift will allow automakers to offer more functionalities, more facilities for this personalization, right? It'll basically be an extension of the entire IoT space that you live in. And so there are four high-level functionalities which have some impact on security and privacy. Okay, so your car will become a part of the IoT system. Okay, it already is, but this integration is going to grow. Okay, and this has a lot of implications on security. Okay. Autonomous driving. So we're all sort of heading towards that. Now a lot of cars are at level 2. I think within the next couple of years, level 3, level 4 might become more commercially available. And so basically, these autonomous vehicles, they ingest a lot of data, about the environment, about the riders inside. So there's a huge privacy implication of these. Okay. There's a fundamental change in the connectivity infrastructure. The cars talking to cars talking to roadside infrastructure, right? Again, this will have security and privacy implications. There is, again, because of this fundamental change in the architecture of cars. So if you've never worked in the automotive industry, what you don't realize is automotive industry works in a very siloed way. So, Bosch supplies something, BMW will take that something, it'll put it in a car. It's a very siloed group of companies which provide some specific components. And because of these large ECUs that will come into play in future cars, the software development part will also become more collaborative. Okay? And car companies actually don't want to share data with each other. They don't want to share code with each other, and we'll see a specific problem with that. So the model of cooperation will change, and this has a lot of security and privacy implications. So if you talk to anybody in the SDV domain, they will point you to security problems. Okay, they're important, and we cannot ignore them because they impact the functionality of the vehicle. But there's enough people, in my opinion, who are focusing on this, right? But just for completeness sake, in case you want to sort of see the bigger landscape, just one slide on the security problems. I mean, if you look at the picture on the right, the number 2 on the right, so there's going to be these powerful nodes which will run a lot of components on a single node, right? So think about your braking system running on the same system which controls your seats, which controls your radio, right? Somebody goes in through your radio, they can also now control your brakes. And this does happen even in today's cars. So there are attacks because of this whole broadcast medium that exists within cars, that somebody can hack into the radio, they can control your steering, they can control your brakes, right? So it's not unheard of, but if everything is running on the same processor, this problem becomes bigger. Okay? Because of connectivity, I think we know cell phones get attacked. If the car is going to be an extension of a cell phone, the probability of attack increases. Right? So privacy is also important. And like we said, there's not enough people talking about it. So I want to touch upon like 4 different aspects of privacy for automotive. Okay. So there's the design phase. So when cars are designed, there's a privacy problem. So this is a little bit of an abuse of notation of privacy, because it's not privacy in the typical sense in which you think about it, like user privacy, but more of privacy from a company point of view. Right? So to get political, companies are people too, so they care about their IP and their code. Within the design phase, there's problems with GDPR compliance, again, in context of autonomous vehicles. In use phase, so a lot of personal data is collected by cars. So there is going to be a privacy problem there. And then when you take your car to a service station, or when a car reaches the end of life, there's still a lot of data on the car. So there's a big privacy problem there. And I want to just sort of briefly touch upon all 4 of these aspects. Now, one thing I should clarify, the privacy problems are not necessarily unique to SDVs. They can exist in cars today. They just become amplified because of the SDV architecture. So just as an aside, these are a few recurring privacy enhancing technologies that I'll be referring to within the architecture proposals that we have. So just as a few examples, so there's something called trusted execution environments. Anybody familiar here with trusted execution environments? Okay. So,
sorry, can we do that?
So trusted execution, most modern processors, they have a hardware extension. So Intel has it, ARM has it, AMD has it, which is specialized hardware that you can utilize to run these things called enclaves. And the enclaves are a very protected, a very protected area within the execution pipeline. And if you're running a regular OS on your main processor, something that's running within the enclave is protected even from the admin of that OS, right? So that's what you can think of it as at a high level. Another paradigm exists, something called multi-party computation. Again, this is a cryptographic tool which has existed for almost 3 decades now. It's starting to become a little more practical now. So here what you're doing is basically, if you have any data and you want to do any computation on it, you split it to parties which might not necessarily cooperate. And there's a specific way in which you can split this so that you can do arbitrary computations on it, right? It's a little less efficient, it's actually quite less efficient than trusted execution environments, but the guarantees that are but it provides stronger guarantees because it's mathematically provable. Again, what both of these technologies allow you to do is, if you have any computation, you can basically do it in a privacy preserving manner. Okay, so these become important tools for any, if you want to increase the privacy of the system. Another common method is statistical disclosure control. So if you've heard of things like differential privacy, right? If you have any data, like if you're querying any database, you can add some control noise to it, so that enough noise so that you don't spoil the utility, ruin the utility, but you still get some noise of the privacy. Right? Again, this is mathematically provable, so it's a great tool for privacy engineers. But it's a bit difficult to use because the utility comes into the picture, so you have to sort of custom design a scheme for your application. Now, how do these things apply to the automotive domain, right? So the way that car design happens today, so these 100 different components that we talked about, so companies basically give hardware pieces to the end OEM, so like BMW, who basically create like a dummy vehicle and they test everything. Okay, so these are hardware in the loop setup boxes where they do all their testing and everything. What's happening is all of this is moving towards software. So the complete pipeline for simulating all these ECUs will be all software, right? For somebody who's not been in the automotive industry, it's pretty intuitive that this is the way it should be done. That's how we do everything, right? We simulate everything in software. But this is a big step forward for the automotive industry. And so this is called software in the loop. So basically you take all your models. So you have your brake, you make a model of it. You have your windshield wipers, you make a model of it. You have an environment in which the car runs, you make a model of it. Everything is connected through a virtual bus in a simulation environment, and you test and design your own whole car. Okay. And this, of course, has a lot of advantages, but this is sort of what this looks like in the real world, okay? So you have, for example, the brake system ECU coming from one provider, the powertrain coming from another provider as models, right? These will run on some cloud system, right? Which might not be owned by OEM. So BMW doesn't have its own cloud system. It will go out to Azure and it will use that cloud system, right? To run a distributed simulation. If you do a threat analysis of this, there's huge holes that can be exploited, right? There's potential for IP leakage everywhere. And each of these virtual models basically have IP worth several millions of dollars, right? So a company like Bosch or a company like Conti is very sensitive about sharing this without security. And a lot of the times, when you're running these collaborative simulations, so there are models coming from companies which are cooperating for this, but are actually competing, right? So for example, Bosch would compete with Conti, but they might just both be working for different parts of the vehicle, right? So the whole dynamic of interactions becomes very complex, right? And traditional methods for ensuring that my IP doesn't leak are insufficient, right? So basically, the big research challenge here is how do you get these competing parties to actually collaborate, right? And the key thing that you want to protect here in the sense of privacy is the IP within each of these models, right? So for example, if you have an engine model, the tuning parameters of these engine, there's a lot of engineering effort spent on those, right? So those parameters are actually quite valuable for companies to protect. And you have similar cases for almost every component. So how do you actually protect all of this while still being able to work together without extensive legal agreements, right? So of course, legal agreements is how it's done now, but can you have a technical framework for this? So one thing which we've been looking at in our lab, and we've been trying to push this out to the standards bodies. So these privacy enhancing technologies that we saw a couple of slides ago, so let's have a black box like that, right? So if we can create these black boxes or these secure execution environments, which have these properties that you can bring data into it, you can exfiltrate data from these, right? And whatever happens within these black boxes is not visible to anybody. then you could, in theory, right, uh, think about putting these models inside these black boxes as they run in a simulation environment. Okay, and that would solve your privacy problems, right? But the thing is that implementing these black boxes is not very easy, right? So Intel has a framework to do this. Uh, AMD also has a framework to do this, but utilizing this in context of automotive environments is extremely challenging, right? Just to give I mean, not to trivialize the problem, but almost all the open source work which happens for SGX, for SEV, as an example, happens for the Linux environment because nobody wants to use Windows in the real world, for large scale simulations, except the automotive industry. So even taking everything and just shifting it to Windows is a huge, huge, huge engineering effort, right? But then there's research challenges there as well. And of course, there's integration issues, right? You can't take a shiny new research solution and take it to a design engineer and tell them, okay, I'm going to change your entire workflow. Use this because it's going to give you more protection, right? No research engineer is going to accept that. So how do you actually integrate these black boxes in a way so that it can be used with existing tools, right? So how do you make sure that the interfaces are still the same? How do you make sure that it still runs without too much overhead? These are all challenges that there's still no concrete solution, right? So no widely accepted solution. Now, I mentioned that these are simulation environments into that these companies provide. Now, to give you an example, even creation of these models themselves runs into the same problem. So, for example, to create these FMU is a model of a component. You would have source code coming from one party or two parties, data coming from another party. Even these parties don't want to sort of have a collaborative pipeline, right? I mean, you can imagine. So the way that this is done today, everybody. So to iterate over one cycle of getting a binary out with some small updates is of the order of weeks, right? Something that you would imagine can happen in a day happens in weeks because, again, lack of trust, right? Everybody's very protective of what they're writing. So the same story, essentially, of these models also applies here, right? And in theory, the same solutions can also be applied here. Again, different domain is more towards the CI/CD pipeline, but the same use of trusted execution environments or multi-party computation can also apply here. By the way, if anybody has any questions to clarify anything, just stop me in the way instead of waiting towards the end. Okay, next, another aspect of design that. So think about all these cars. I mean, Pittsburgh is a hub for autonomous vehicles. So I'm sure you've seen like companies driving their cars around, right? And they're collecting video data, LiDAR data, sometimes even audio data, right? You do the same thing in Germany or Europe. There are legal restrictions around it, right? So there's something called GDPR. I'm sure that being privacy engineers, you've all heard of that. GDPR has very strict requirements on when you can collect the data and when you can store it, right? So there needs to be some lawful basis. You need to have some sort of consent, or you need to be able to demonstrate legitimate interest, right? Now, a lot of these self-driving car companies, this restricts on what you can use the data for because they don't always necessarily know what the end use of that data is going to be, right? Yes, they will treat their self-driving pipeline, but what that pipeline might look like, or if there's other potential uses, they don't know all of that, right? So what happens is, if you see Bosch cars driving in Europe, there'll be a big number around it. If you don't want to get tracked, call this number and we'll delete your data, right? Or when the data is collected at the source, there's things like blurring of faces and blurring of license plates and things like that. So this can be a huge problem. It's not such a big problem in the US right now. And even companies which are sort of collecting data are almost skirting around this issue, right? Because they care more about the functionality, let's get the car working, than the legal aspects of it. So nobody's been sued over this yet. It's not a huge problem, but it should be a huge problem, and people should be concerned. So this is a pipeline that we've been toying with. So the way that the pipeline currently looks is, you have data acquisition, you transmit it. So normally, these cars, when they park at night in the bay, so the data is downloaded. You store it somewhere. Somebody actually does labeling on this data, and then you do training for it. And what the pipeline that sort of we've created is, let's, instead of storing data, just plain data, let's use these privacy enhancing technologies that we had to actually store this data, right? So instead of regular databases, let's use a database which is protected by T, or which is protected by these, it's distributed over multiple entities, right? And let's use these same privacy enhancing technologies while processing the data. So this is what ideally, the pipeline can look like, right? In a perfect privacy preserving world. So you take the image, right? Let's say a pedestrian walking. You split the image. Now, every use of privacy enhancing technology adds a cost, right? So nothing is free. And you're already spending, millions of dollars building these models. You don't want to spend another $100 million to add privacy to it, right? So what, in theory, could happen is you do some sort of a semantic segmentation at the edge, where you extract all the personally identifiable information, right? You store the different types of data with different degrees of protection, right? So if it's a tree, you can store it, with no protection, maybe. If it's a person, then you have to, use some degree of protection. If it's a house number, then maybe there's more protection. And you can then have, based on, what sort of data it is, have different types of labeling environments. Again, labeling plain data can be cheap. Labeling a person data, which has to be done through very trusted labeling companies, or has to be done in-house, would be more expensive, right? But then within the T, you can combine all of this and then train it, right? So that's the beauty of all these privacy enhancing technologies. It gives you the ability to actually combine all of this in a privacy preserving manner and do your training on it. Now, the challenge here is, right? So to give you an example, if you just try to use, hardware companies have done a good job of making the process of using trusted execution environments efficient, right? But just plain old usage of it comes with like a 2x or a 3x slowdown, right? So if you're spending $100 million on your cloud compute, you basically made that into $300 million. And most companies will not tolerate that, right? The amount that companies are willing to tolerate for privacy, in the name of privacy, unless mandated by law, is like 10%. So how do you bring the cost of this pipeline down to within that 10% range is an open research challenge, right? A lot of course, training happens on things like, GPUs, NPU. Again, the extension of the secure environment from processors to GPUs, that's something that's just starting to happen. So for example, NVIDIA has a product which does that. NVIDIA allows you to securely integrate your GPUs with trusted execution environment. But it has to, it's not there for all the custom silicon that's made. And that has to really increase if these systems have to be used in commercial. Okay, any question before we switch gears to more user centric stuff? Okay. So next is privacy of data during use. So I'm curious, like as a show of hands, how much data do you think a car collects about you? Any idea? What can a car infer about you? What's the worst thing that a car can infer about you?
I know mine has learned my home and work locations.
Yes, that's one. Any other? So to give you, I'll show you a report, but to just give you a small example, Nissan in their privacy policy, and this was exposed by Mozilla's report, actually has a specific clause of determining, the car can determine when you're having sex in the car. That's how much it can infer. So, like, the amount of data that a car collects it's unimaginable. Yeah. So the reason why cars are collecting so much data is, there's a lot of personalized services that car companies want to offer, right? So, for example, insurance, right? If you had insurance with one of the big insurance companies here, they'll offer you a dongle where you can that you can plug into your car. It'll collect your driving data and it'll reduce, in theory, it will reduce your insurance rate based on your driving data, right? You can also increase it, so be very careful. If you drive bad, don't do it. There's also benefits like predictive maintenance, right? So if my brake is about to fail, I would want to know that a month ahead of time, right? If my car can tell me that, that's good. So there's value in what services that can be provided, right? There's a lot of if an accident happens, who's at fault, determining who's at fault. If you have data from a car when an accident happened, you can actually determine who's at fault accurately, right? If cars are talking to each other, you can have safety collision avoidance methods, right? So there's a lot of good, services that can be provided. This figure is a little bit dated, so it's from 2017, but there's significant amount of, PII data that can be collected from cars, right? I mean, the easiest thing is, for example, GPS, driving behavior, right? It's very easy to determine based on your steering data if you're driving drunk. A lot of cars have cameras mounted inside now. A lot of cars, for example, have ultra-wideband sensors. So when you walk to the car, it opens. There's ultra-wideband receivers that transmitters and receivers which enable that. Those same ultra-wideband receivers can actually also determine your heart rate. So just to give you an example, that's how they can be used to do that. So there's a lot of information that can be collected and that will be collected in future cars. These are just, this graphic is still pretty scary, but this is a very small example.
You said will be collected.
So car companies, in theory, want to collect everything, right? And sometimes the people who are actually designing these systems don't even know how the data will be used or what will be collected. And I'll come to an example of that for
the current privacy regulation hasn't kind of pictured that.
It hasn't yet. It's good conversation, with a glass of wine, you swear like, yeah, we'll do privacy, but yeah, it really hasn't prevented stuff.
I guess the technologies do have a lot of work benefits, but does the NHTSA or the DOTs have any regulations on to the extent of how many technologies they can have that can collect drivers?
Not that I'm aware of, nothing yet, right? So there are some states which have limits, right? So I think, for example, Wisconsin has limits on collecting facial data inside. So if you're driving the car through Wisconsin, in theory, your facial recognition inside the car should switch off, and then while you're out of it, then it should turn back on. There's almost nothing at the U.S. federal level to do this, right? And a lot of companies, automotive companies are not doing this because exploring the data side of stuff for automotive companies is very new. Other countries in the U.S., the big FANG companies, they're pretty actively trying to subvert any federal regulation, right? So it's very unlikely that there is a strong federal regulation that will be passed in the U.S. There's a very strong lobby. Kind of makes sense. Okay, so in theory, if you have personal data, right? So again, privacy is a matter of choice, right? So it's not that collecting data is bad. It's collecting data without providing choice to you is bad, right? Or without providing information to you is bad. So in theory, to have fair practices or to collect data, there are three requirements that you should fulfill, right? So transparency, so you should know how your data is collected, how it's used, some degree of control, right? And some degree of confidentiality that you can choose about who the data is shared with. Now, this is, again, like I said, these do not reflect the views of Bosch. Let me be very clear, right? So I'm not speaking on behalf of the big company, but as a researcher. So if you think from a privacy point of view or from a transparency point of view, the current state is literally non-existent. Okay, and even if some privacy mechanisms exist, they're very, very deep within the fine print. Okay. There was a recent study done, which got published in the New York Times. So people who were buying GM cars, all of a sudden started noticing that their insurance rates are going up, okay, for no reason. And this was happening with all GM cars. And it turned out what was happening was GM was taking all car data and selling it to LexisNexis, which was aggregating all the data and selling it to insurance companies. So indirectly, GM was doing the equivalent of putting that dongle in for anybody who had signed up to OnStar. Okay. Now, GM in theory provided choice for this. So when you go buy the car at the dealer, there was a checkbox that you have to tick that, okay, I consent to using OnStar and collecting my data. But the dealers were motivated, were incentivized to get more people to sign up. So to make it convenient for people so that they don't have to do all the paperwork, the dealers would just check that box and quickly go through that prompt. Right? So people were basically signing into this without even being informed. Right? So that's the state of, again, it's not unique to automotive companies, but just think about, like a car, the amount of data that a car can collect, right? So it becomes significant in that context. But a lot of companies use practices like this, right? If you've heard of the term dark patterns, it's not, it's everywhere on the internet. But now car companies are also starting to use this. This is the Mozilla report. So if you've not read this, it's really worth reading this. So they've gone through different car companies' privacy policies. And, there's some pretty interesting stuff and insights there. So what does the solution look like, right? So the first thing is actually, I think people need to, talk about it, right? Or people actually need to be aware. I'm curious, how many of you have ever bought a car here? Like, you're all students on you, right? If I was to tell you before buying a car that your car is going to collect all this data, and if you have another choice of a car that doesn't collect any data, would that impact your choice for the ones who bought a car? It would.
Maybe.
So you're all into privacy, so it's good that it does. And we need more people to be able to choose a car which is more, privacy respecting, right? But for most people that I've talked to, they wouldn't care. Okay. It just doesn't, because for most people, it just doesn't register like what sort of privacy violation the car can.
Are there any alternative companies which do not sell information about these?
So not all cars have equal degree of data collection, right? Cars like GM are obviously not doing a very good job. But if you go for a European car, then it's a little more sensitive towards it. Right? But that's the thing. So until consumers are actually using this as a metric to decide which car they want to buy, there's no incentive for car companies to not do that, right? So there's only two ways companies change. It's either consumers don't want a product or they're forced by legal laws, right? And this is sort of the first bullet here that, we need stronger legal frameworks for this, right, which don't exist today. The hope is that the legal framework will nudge this in the right direction, but at the end of the day, it has to come from the users, right? And to give you an example, so there's a company called Privacy for Cars. and so the CEO of that company, Andre Amico, so he's been basically been the loudest voice for automotive privacy for a long, long time. Okay, and he's been sort of pushing for this thing called the privacy rating for cars. So, like back in the day, you know, adding safety features to cars was a cost overhead. And there was a need to motivate consumers to sort of value this, right? So then NHTSA has this safety rating that they give to cars. So it's a 5-star rating or 4-star rating or 3-star rating. And once they started doing that, then consumers started looking at that rating to buy cars. And that led to a race of every company sort of wanting a 5-star rating, and they would invest in safety, right? So now every car has these 1,000 safety features, and they're all the same, but they're all very safe.
Adding to that, do you think it would adversely affect in privacy cases where the companies say that we'll collect more data, but you'll get it at $10,000 cheaper than what you would pay for it?
But so I think if they're willing to provide that, that's still good, right? Because again, privacy is about choice, right? I might be willing to give my data for $10,000. That's what I value my data for, but it's my choice and my control.
You're saying right now there's no choice.
There's no choice. No.
I think you might have already explained this, but my question was whether these are on separate platforms, but I also never bought a car and haven't checked consumer reports for cars, like if these are integrated into existing reports for cars.
Yeah, so that's the proposal, right? So this guy, these people, so this privacy for cars companies, so they've tried to develop this sticker. This vehicle has privacy, good privacy policies. They have a dashboard where you can put the VIN of the car and it'll show you the data that the car collects, right? And the hope is that these things become mainstream enough that they become, it's equivalent to show me the Carfax, right? So there's a show me the privacy policy, right? But again, that's still a ways off, right? So next thing is about control, right? So again, even if you know what's being collected, do you have the ability to control it, right? Right now, it's a very binary choice. So for example, when I go to Europe and I check the box, somewhere buried inside the console that I don't want my data to be shared, they turn off the connected services. I don't have access to those services anymore. It's some degree of control, but it's a very binary thing. So I either give them all the data and have access to the center console connected services, or I don't have any access at all, right? Which is, again, not really a good choice. There's no time restrictions on sharing, okay? And the controls are really buried deep. And just to give you an example of the time restrictions, right? So the 3 pictures on the right, so when I I'd gone to Germany in 2019 and rented a Ford Focus, and I used the Ford app to unlock the car and everything. As of today, I still have the ability to unlock the car, to track it, to know what the fuel level is, how much pressure is in the tires, right? I still have that today on the app. So these are recent snapshots.
Yeah, I was going to mention that these controls don't seem to support multi-user
Exactly.
permissions, which can be the case for owned cars too. So you're renting in this scenario, but multiple people in a household would share a car too.
Yes, and I mean, multiple people in the household, or like you said, old cars, right? So when you sell your car, you really move your data,
Yeah.
right? And I have a small slide on that also towards the end, but there aren't enough people concerned about it yet. So there isn't enough being done, right? So again, like I said, this privacy for car companies, they do have an app which will tell you. So normally the clearing all your personal data from the car, it's not on the first screen of the car, right? It's buried within 4th or 5th or 6th screen. So this app will tell you, okay, go here and delete the data, right? In theory, how I want at least the fleet cars to work is I return the car to Hertz and all the data is just wiped out the next time somebody rents it, right? There's no reason for my data to stay on the car. And if you ever want to sort of get if you have some free time, like listen to talks on automotive forensics. So there's a lot of talks on YouTube. I mean, there's a person called Noel Loudon based out of UK. He's a expert, forensics expert. Just listen to some of the talks about the data that they're able to extract from cars. Again, this is in context of solving crimes, right? But it'll really, I mean, you'll feel scared about how much data is actually stored there, right? I mean, there was a case that he had once described where they solved the crime basically because apparently the door opening within the car was stored in the car somewhere, and they were investigating a crime scene. So the car drives to the forest, and they noticed that the difference in the timings of the door opening was such that two people got out, and when the doors were closed, it was so that one person closed it and somebody walked around and then they closed it. So just based on door, so there's a lot of data that's stored. Right? And these forensics talks are pretty interesting to see what sort of data actually exists. The second thing is, so even with this choice, so if you've been using Apple or Android for a long time, so you'll see that the privacy controls within the cell phone has evolved over the past decade or so. Right? And there's a good chance to use these trends in the automotive industry as well, right? So Apple does a pretty good job of, like take photos, for example, right? Selective photo sharing. The equivalent of that in automotive. The third thing, again, is confidentiality, right? So we do know like a lot of data goes that there's good services that can be provided. From a research perspective, there are good tools available, things like differential privacy, right? Or statistical disclosure control, which I mentioned earlier, to prevent or to add noise to this data so that you don't necessarily give up all your privacy, right? And this can be done in context of sharing this data with multiple parties, right? But just to give you an example of how difficult this problem can become for automotive, right? So a typical differential privacy tool is you have some observation, you add Gaussian noise to it, with a certain variance, and if it's within certain bounds, you can say that okay, my output will be differentially private, right? Now, in a car, it's been shown that with your velocity, so with your speed data, which can be obtained from your RPM, and your steering data, you can actually figure out where somebody's going. Because you take the velocity steering data, you overlay with it on a map, and you can basically compute somebody's trajectory. And there are academic works, but we show that this is feasible. Okay. Now, if I add, let's say, Gaussian noise to my steering data, right? In theory, differential privacy says that should make it private, right? But if you think about it from overlaying it on a map point of view, right? Adding the Gaussian noise just makes you look like a drunk driver. You're still on the same road, you're just going all over the road, right? So it doesn't necessarily solve the problem of privacy. So applying even existing tools, which are sort of well studied, to the automotive domain or to automotive data is not very easy. Right? For example, applying synthetic data generation in a privacy-preserving manner to CAN data. There's a professor here, Vyasekar, who collaborates with us for that. Again, a very difficult problem to get good quality automotive synthetic data. Am I doing on time, by the way?
We're here till 1:50, so yeah, plenty of time.
Okay. Now for service center. So again, like I said, one of the big sells for automotive for wanting to collect data is that they can offer predictive maintenance, right? Service centers want to use the data on your car to upsell you or to say, okay, next time you'll have to come in after 2 months to do this. A lot of companies, so for example, Bosch has a lot of Bosch certified service centers. There's restrictions on how much data can be collected, again, Bosch being a German company, because there's some antitrust regulations and because of restrictions around PII in Germany. right? But there's still benefits of doing this. So we have tried, again, this is a research prototype, not yet deployed, but again, potentially using things like multi-party computation or using the privacy enhancing technologies that we talked about earlier, it can alleviate some of these privacy leakages or some of these pain points around PII collection or antitrust regulation to offer better services. So basically, you process the data that's collected from multiple workshops within a trusted execution environment. You'll need to add some differential privacy to this because again, there are instances where this data can have outliers which can enable easy identification. But it is possible to sort of collect this data, use it, and still offer services in a privacy-preserving manner. Now, coming to the last point. So this goes more along the direction of end of life, right? This is, I think, now a couple of years ago, there was a study published out of University of Maryland for cell phones. So what they did is they went to auctions and they bought cell phones which were sold at police auctions, okay? And they noticed that a lot of these cell phones didn't have a passcode, or the passcode was with a sticky, it was on the cell phone, so that you could buy at an auction, right? And they saw that a lot of these cell phones had credit card information, social security numbers. So basically, these cell phones belong to, some victims of prior crimes, and because of the leak of this data, they could be victimized again. Okay, it's a pretty interesting study, and in some sense, the car is going in the same direction as a cell phone. Okay, so the car will have, future cars are going to have payment options within the car, right? So you're not going to have an easy transponder. You won't have to pay by apps. You'll have a wallet within the car so that the car can pay for itself when you park it somewhere. Or if it's driving on a toll road, it can pay for itself, right? So these things will become, a central component within the car, which means that a lot of the personal data that exists on your cell phones will also be present on your cars. Okay. There are, again, if you attend, suppose, automotive security conferences, people have gone to junkyards, they've bought the center unit of, say, a Mercedes-Benz or something, and extracted a lot of data from it. And this is in cars today, and this problem will become much bigger in cars in the future. And there aren't too many people, again, thinking about, how do you deal with personal data towards the end of life for cars, right? So again, if you want if you want an interesting problem to work on, so all of these are interesting problems, they won't necessarily become practical, so you can't necessarily sell these solutions to companies today. But in the future, these things will be, these checks and these technologies will be required. So yeah, this is just something to think about, like how do you actually build a data-focused supply chain for the end of life for cars, right? Again, this startup company, Privacy for Cars, they've been vocal about it, not much done yet, right? I haven't heard any OEM talking about it, any tier one talking about it. So, few final words, right? So, these are just examples, and hopefully, some scary examples for what can happen, right? I think automotive companies in general are not used to seeing themselves as software or data companies or data brokers. And there needs to be a change in the privacy engineering culture. There needs to be a privacy engineering culture in automotive companies. Some of the companies like Google, Meta, who have been doing this for years, they're a little more ahead of the curve. There's dedicated teams, for example, for red teaming and context of privacy and some of these companies. The automotive industry is still catching up, so we still have ways to go. But again, there's a lot of change that needs to happen both at an organizational level, at a technical level, and at a management level. One thing, and I would sort of open this to academia to participate in this. This also applies to security, but both security and privacy are collaborative ideas, right? So again, because of the siloed thing, the access for academics to automotive resources has been limited, but that's changing, right? So the automotive industry is starting to embrace open source. Um, and there are a few efforts. For example, Automotive Security Research Group is one example. They have an academic chapter which tries to connect students to companies so that they can access data or resources. Uh, so if you're, I mean, things like Carbine Stack, which is privacy, which is development of open source privacy enhancing technologies. Bosch is a participant in that. Honda is a participant in that. We have a few universities that are participating in that, right? You can contribute to that. There's a few projects happening in the Eclipse Foundation. Have a look and see if you can come up with new ideas, new thoughts, new directions. We need academics to come and contribute to this. And with that, I'll open it up to questions.
Thank you. Let's do a round of applause. I know we had a few questions during the talk, but yes, there's.
Yeah. So do you think like we have done? You said that we've done a good work, and like at least we're doing good work in terms of privacy, in terms like iOS and Android. Do you think like treating the car as a mobile phone or an appliance will solve this thing, or?
It would go in the right. So I think there will be challenges which are unique, right, to automotive, but I think it's good. It would be a good starting point, right? And I think a lot. So I mean, both iOS and Android are actually making a big play for this in center console for cars. So it's likely that some of those controls will go in, but it might not be the whole the whole solution.
Just a follow up, like as far as the most of the cars, the central console, and it's either one or the other, like a derivative of Android, or it's just a customized version of Android that's done by the company. So I think we can implement some privacy features in that. And I think the most challenging part would be like the sensor data collection, the CAN bus, and how many RPMs. I think we need some different technologies for coping with that.
So it goes both ways, right? So yes, I mean there are variants of Android which are used, right? But that's not necessarily. I mean that's not the entire space. A lot of companies are actually developing their homebrew solutions, which deviate significantly from what Android should be, right? So they use stock Linux and run it and provide a UI on top of that. So if it all goes towards Android, then yes, maybe. But then to the second point that you said, right, like what data actually contributes to privacy leakage, right? I mean, for example, like with GPS, somebody can intuitively think, okay, GPS data is privacy sensitive, right? But the fact that you can get the same information by steering and speed is unique to cars, right? So that's something that that somebody needs to, you need more results and more people looking at the data to understand what data could be privacy sensitive. I don't think there's enough studies for that yet.
We have a question on Zoom. So kind of given the increasing capability related to autonomous and connected vehicles, there's concern about how the companies themselves are kind of collecting, storing all of this data. But what safeguards do you think are kind of the most critical to ensure that this data isn't misused by third parties or kind of the parties that aren't the ones that originally collected this data? Especially when we think of things like connecting our phones and how much information our phone has as well.
Yeah, so in terms of safeguards, like right now, the business model around the data is still being figured out. So, car companies don't necessarily have a good idea of what the business model around data looks like yet. So safeguards is then a secondary thought after that. So, as of today, yes, companies which are collecting data, they'll have standard best practices, but with regard to sharing, again, they might mention it within their privacy policy that they'll share this, but it's buried somewhere and nobody will actually go read it, right? So there are these standard checks and balances which exist. we have a legal agreement and we do everything according to a legal agreement. How useful that those safeguards are, I mean, I would really question that. I think it's a evolving space because, I mean, we're still in early days of data collection for cars, so this problem will get figured out later. But for now, yeah, it's just read our legal fine print and hope that we do everything with, on that basis. Again, I don't speak for any OEM. Since this is being recorded, it's a,
So you mentioned that at the beginning that the car manufacturing companies are very incentivized to protect their IP, but they're not as incentivized to protect user privacy. So do you see any ways in which, like the ways that, like, say the car manufacturing companies are using to protect their IP and how they can translate to user privacy protection, such as like the trusted execution environment and all the various simulations that have been run?
so I should also clarify. So right now, what's being used to protect IP are also legal agreements. So there are this architecture with the trusted execution environments is something that Bosch is sort of promoting, and there's standards body, VDA, where we're trying to get this within the standards of still tools. It's still not, widely used. It's clear that based on the developments that are happening that this will happen, but it's still, legal agreements are still the way to go, right? So if that's the benchmark for protecting your own self, then you can't expect more for consumers, right? So that's why legal agreements sort of become the benchmark for consumers also at this point. But in the future, right? So these software-defined vehicles, for example, because these are now bigger micros, for protecting keys, which are really used for communication within the cars, there's going to be trusted execution environment within the cars themselves. To protect wallets and credit card information, there are proposals to have hardware-based security. Hardware-based security for wallets, right? So in theory, the same things can also be used for protecting personal information and PII data, but it's still not done. But I would like to see it happen that way, but yeah, it's still a ways off.
I have a quick follow-up question. Because you mentioned the system simulations at the beginning. I'm just curious as to how well they translate to the real world setting.
In what sense? Like how?
I think like at the beginning of your slide that you mentioned that there are some system
Yeah.
simulations.
Yeah. The simulation environments themselves. Are you saying like what's the gap between the real? Well, yeah. So I think the simulation to real environment gap in automotive is pretty small, but just because of legal regulations around safety, so simulations are not an accepted framework for testing your car. So it's good for iterating and designing until you get somewhat close to a final thing, and then eventually everything has to be done in hardware. So again, I don't work necessarily for the design guys, so I don't know exactly what the state of the art is for that. But from the discussions that we've had, it seems that simulation environments are getting close to real. So a lot of companies are starting to use this more and more for their design.
Thank you.
We have another question on Zoom related to kind of policy or legislation, which I think you touched on before, but I guess maybe we can talk more about that. And what would you like to see in legislation kind of related to kind of data collection by cars? And would you say would a federal level general purpose privacy law like GDPR be sufficient, or is there kind of more specific things related to cars that?
I think you need multiple. There's multiple aspects of it, right? So, I think like Lori and Yuvraj, like they've been pushing a lot in the direction of these nutritional labels for IoT devices, in context of privacy. If you could have something as simple as that for cars, that would be a good starting point, right? Again, if if somebody like NHTSA could regulate that, okay, we need this for all cars, and that would inform the consumers more, I think that would be a huge first step, right? Things like GDPR uh, work, right? But then, like for example, when we saw this OnStar data collection in GM, right? They do have a checkbox that you have to tick to consent. So in theory, they are collecting consent, and if there was a law like GDPR, they would be compliant with that. It's just that normal end user is never really given the option of checking that, right? So there's ways. I mean, this whole realm of dark patterns, and I mean, that still falls within the confines of GDPR, but you can still collect data. So I think providing information clearly to consumers, if we could sort of advocate for that, I think that would be the biggest impact that a law body can have. And other things, I think, if consumers are more informed, then other things will just naturally follow. Because if car companies are getting shamed because of the data that they're collecting, then they will improve their data collection practice and their data use practices. So. Okay. If any of you want to reach out later.
Sorry, I have one last one. So, I mean, as things kind of move towards, level 3, level 4 automation, what new privacy challenges do you see arising, or is it existing ones will kind of be exacerbated?
I think a lot of the existing ones will sort of become, I mean, so as you go towards more autonomy, right? Right now, the car is a functional space, right? With more autonomy, it'll become more of a personal space rather than just a pure functional space. So then you will have more, more preferences being embedded into the car environment, right? Again, with autonomy, there will also be more street level data collection or more environmental data collection, which itself would then make the problem worse. We've seen examples of this Tesla Sentry mode. I think there's been a couple of exposures of that, right? Again, that's just one example of how it can become bad. If you see the patent landscape, again, these are not commercial products, but if you see like some of these OEMs, they file patents of, when they're driving through your neighborhood, they will see what cars are parked in your neighbors' garages, and they'll give you recommendations on that basis. They'll show you ads on that basis. So there are companies which are thinking of that, and they filed IP for that. So it's going to become worse, but it's just a bigger version of the same problem.
Go ahead.
Yeah, so if you want to get in touch with me, so my email and Twitter handle is here. Just if you have ideas or have any questions for the day.
Thank you. I say one last round of applause.